Namaskar, my dear friends. So we have seen the switching regulator training sessions. In this session, what we had tried to do is we had seen the design and detail of LT3970, right? So in this particular session, what we'll try to understand is this particular IC, which has the application of like automotive battery regulations, power for portable products, industrial supplies, and all these things. And already we have seen what are the things that we need, like how to choose the input capacitor, how to choose the output capacitor, how to set the output voltage using the feedback, like voltage pin, how we can select the inductor selections, and all those things using the this is the particular data sheet for this particular switching regulator, which is LT3970. Now why we are doing this? First of all, you have to understand, like, it is not about a particular device that we are seeing right now. With this particular understanding, what you will be able to do is what are the different important things that you need to know from the data sheet. Okay, that is one thing. Another thing is how quickly you can grasp those informations from a particular data sheet of a switching regulators, and then you can utilize them to design your particular circuit. And if you take any of the application circuits or any of the ICs that you need to design for your own application or own particular application, you should be able to use this particular understanding throughout the engineering, right? So let's get into the application circuit directly. So what we are going to do is, since we have already known complete information about this particular data sheet and what are the informations like input voltage range, output voltage range, current capacities, and everything. So let me just give you an understanding of 3.3 volt step down regulators. We'll see almost all the applications that the data sheet has given, and what is the main thing that we need to just make changes so that the circuit completely works. Okay. So I'll just come to the my presentation itself. So let us say this is the 3.3 volt step down regulator that we are going to design using LT3970. Okay. You can use any other IC also, but the implementation will be same, the approach will be same. And if you understand only one circuit, you should be able to implement any of the hardware circuit that you need to understand for your any other applications. Okay. So let us say we have the input voltage of, let's say, 12 volt. So 12 volt, we have to convert it to 3.3 volt output, right? So you can see 3.3 volt output is converted here. Now I'll suggest you the input capacitor. You always try to keep, like a little bit higher values. You can keep uh, electrolytic capacitor of, let's say, 100 microfarad, and since it is 12 volt, so keep it, let's say, 35 volt rating. Okay, or even 50 volt rating you can keep. Now attach it with 2.2 microfarad is already given here. One more, you keep it zero point 0.1 microfarad, 0.1 microfarad. This is always good. Okay. Otherwise, another option you can do is, this is your input voltage, let us say 12 volt. So attach with, let's say, 22 microfarad or 47 microfarad some two capacitor. Okay. And in addition to zero point 0.1 microfarad. Okay. So this is how you can complete your input capacitance requirement. Okay. So that is one thing you have to keep in mind. Coming back to the setting of frequency setting. So frequency setting, suppose you want to set it for 600 kilohertz, then 226 was there, right? Now the main operation that we have to understand is what should be the output voltage, how we can set it. So to set the output voltage to regulated voltage, which is 3.3 volt here, we have to choose the value of R1 and R2. So how to calculate them? I had already given you the formula. So from the data sheet we can see, let me open this particular Excel sheet that I have designed it for you. So you can see, to get those particular value of R1 and R2, we can utilize this formula, which is R1 is equal to R2 times V out by 1.21 minus 1. Okay. So let us say my output voltage is 3.3. I have put that value into there. So R2 value, if I put 576, then R1 is getting calculated to 995 kilo ohm almost, which is closer to 1 mega ohm. Suppose let us say I want to change it to 300 kilo ohm. Okay. Then it will become 520 kilo ohm or something like that, or 590. So let us say I want to change it to 330 kilo ohm, it will become 570 kilo ohm. So why don't we do one thing? We will use 300 kilo ohm or 330 kilo ohm. This will become 570 kilo ohm. Okay. So this is how you can make changes for your R1 and R2 and get your output voltage to 3.3. Now other parameter that will be needed is inductor selection. So from the same Excel sheet, what we can do is we can go here and see. It depends on your switching frequency, which is, let's say, 600 kilohertz. You can see here for 600 kilohertz, like zero point 0.6 megahertz, corresponding resistance value is 226 kilo ohm. Suppose you want to work with 1.2 megahertz, then that way RT value will become 100 kilo ohm. So this is how you are going to make changes accordingly. Now for 600 kilo ohm, you can see the L value that has been calculated is 20 microhenry. So the closest value that you can utilize for this inductor will be 22 microhenry. That's the reason they have chosen 22 microhenry. Understood? Just understand the current saturation current rating for this particular inductor must be more than this 350 milliampere, which can be, like, as long as let's say 1 ampere rating or 2 ampere rating you can utilize for this particular inductor. Okay. Now coming back to output capacitor, so output capacitor 122 microfarad is given one number. So you can attach more, like one more 22 microfarad plus zero point 0.1 microfarad and connect it to ground. So this will be your complete design. Coming back to your BD capacitor, so BD capacitor 22 picofarad, you keep it as it is. This one, if you want, you can increase it to 0.47 microfarad also. Okay, so that will be your complete design. Okay. Now, moving on all other applications, what you have to do is you have to just try to keep this formation like 22 plus 22 plus zero point 0.1 microfarad at the input. Almost it will work almost all applications. At the same time, you can change based on the like frequency setting that you need, and accordingly there will be change in inductor value calculation. And at the same time, if you want to change the output regulation voltage, so output based on that output regulation voltage, the feedback resistance will be calculated. And at the output capacitors, if you see, if you have little bit higher voltage, you can reduce the capacitance. If you have to requirement of lower voltage, then you have to increase a little bit. Okay. So V out increases, my capacitance value of out capacitance, okay, can be decreased. Okay. Got it. So this is how. Let us go into another applications. This is the application given for 5 volt regulation, which is going to 5 volt, and same current ampere rating, which is 350 milliamperes. So let's see what are the changes that we need to do in this. So you let us say 12 volt is given. Okay. C input you can change based on the previous design. Okay. And C output also you can change it based on the previous design. You make sure that C output all the voltage ratings are, since this is 5 volts, so you have to make sure if you are using ceramic capacitors, then it will be 16 volt or 25 volt or even 35 volt you can use. Okay. But not less than 16 volt you use. Okay. If you are using electrolytic capacitor, then you can use 35 volt with, let's say, 100 microfarad or let's say 220 microfarad even. Okay. But 100 microfarad is more than enough for 350 uh, milliamperes. Okay. Now coming back to the frequency setting that we have already, let us say we have set it to 600 kilohertz only. According to that, what will be the inductor size and what will be the feedback resistance? If you want to change these values, we can change it and calculate it. Okay. So if we open this particular Excel sheet, let us say my output voltage is 5 volt. Now let's say we are going to set the R2 value to 330 kilo ohm, or let us say 570 kilo ohm, or let's say I will just change it to 150 kilo ohm. Okay. In 150 kilo ohm, if you say, this will become 470 kilo ohm. Okay. So what I can do is I'll set it to 150 kilo ohm, then this will become 470 kilo ohm. Okay. So this is how you can change this. Now coming back to the inductor value. So for this frequency setting of 600 kilohertz, you are getting close to 28 microhenry. So closure value is 33 microhenry you can take up. If you increase this value, let us say 1200 kilohertz, that is 1.2 megahertz, then you can see there is a drastic decrease in the inductance value. Okay, so this is how you can gain a knowledge or gain a advantage of reducing the value of inductor by increasing the switching frequency. But very high switching frequency is not good because it will reduce your efficiency, and either you can reduce the magnetic size, but however it is not that sufficient. So let us keep it 600 kilohertz only, and we are going to choose inductor value to 33 microhenry. Okay, sorry, 33 microhenry. Good, so this is also done. Like you have converted your 12 volt regulator to 5 volt regulator with 350 milliamperes of rating for your utilization. If you want, you can change your input voltage to even 9 volt, or even like a 15 volt, or even 18 volt, even 24 volt. So up to 24 volt, I will recommend you to utilize this particular regulator specifically if you want it. Otherwise, you can choose your own applications. Okay. Two more things that were there is enable was there and PG was there that I didn't talk about. So enable, always you have to, what you do is very simple design. If you want to do, directly connect it to input voltage, that's all done. Even in the previous design 3.3 volt, I didn't tell you, you can directly connect it to input voltage, that will be sufficient. Otherwise, if you want to control it, like shut it down, or like switch on switch off based on the application requirement, then you can put an microcontroller IO here, and this GPIO will go high to switch it on and go low to switch it off. So this is different, but I'll suggest you to go and directly put it to the input voltage. Okay. Power good actually gives you the understanding of like whether the output voltage is within the range or not. Like let us say you want it to utilize for plus minus 1% or whatever the accuracy is given. Based on that, it will give you high or low. So what you can do is you can connect it to a pull-up resistor. Let us say I will connect it to Vout itself. Let's say 5 volt with a 10 kilo ohm, and then send it to GPIO of 5 volt tolerant. You just make sure that you are sending it to 5 volt tolerant pin. Otherwise, it will not work. Otherwise, what you can do is you can connect it 3.3 volt also if it is available in your board, and pull it up to 3.3 volt, and then blindly you can send it to your GPIO, which is almost all 3.3 volt logic. Okay. Similarly, there are several other uh, applications are there. Let us say the next one. So next one, if you see, we have again 3.3 volt regulator, which is going to be 3.3 volt regulator, and the change that is going to happen here is this is the fixed one. Okay, so we had the option of LT3970. So these were variables like adjustable ones, which require the feedback resistance design. Okay, and based on that design you can regulate your output. Similar to that, 5 volt was also there, which was requiring the adjustment of your resistor divider, so that you can regulate your output to 5 volt. Okay. Now coming back to the fixed voltage regulators, which is having fixed versions. So if you utilize directly fixed version regulators, you don't have to do any other like resistor divider changes. You can directly connect this V out or FB pin, both are same, so that connect it directly to your SW inductor. Okay, directly SW inductor. So this is how you will get your output, and rest all C input, C output. You make changes what I showed you in the previous slide, and same way you can attach it to input and send your PG. If you want it, you can send it to your microcontroller for your status. Okay, similar to that, 5 volt regulator also with a 5 volt um, fixed version. What you can do, make the same changes as we did in here, input capacitor, output capacitor, and just only the change that is there here is you don't need the feedback resistance requirement. It is going to give you fixed value, which is 5 volt output. So the resistor divider actually already there, which we had seen during the design and detail section of the uh, data sheet, where the feedback resistor was inbuilt inside the IC. Okay. There are more applications, as you can see here, with variable version. If you want, you can design 2.5 volt regulator also, because these are generally used in your 2.5 volt logics. Okay, So let us say we have to convert my 5 volt input to 2.5 volt output, okay, or let us say 12 volt input to 2.5 volt output. So since it is switching regulator, up to 12 volt is actually a good idea. If you increase little more, let's say 15 volt or 20 volt, 24 volt or something like that, your efficiency will reduce, the output efficiency will reduce a little. However, it is well recommended to utilize it for up to 12 volt or 15 volt. That is sufficient, okay. The basic changes that I already told you, C input, you make changes as accordingly to the previous requirements that I told you. Now see the output capacitance. As I am telling you, the output values, output voltage level is going to reduce. It means you have to increase the value of capacitance. So increase a little. If you want, you can put one more 47 plus zero point 0.1, you put one more. Okay. So 0.1 is actually needed. In input side also you put 1.1 microfarad capacitor. Okay, that will be good for your smoothing purpose or your noise filter purpose. Okay, and the other changes will be connect input to your input volt and enable pin to your input voltage. If you don't want to use, you disconnect this PG. Now coming back to this particular inductor size, so inductor size, what we'll do, just open Excel sheet and then make this output voltage to 2.5 volt. Okay, so I have calculated it for you for 2.5 volt. My inductor value according to this will become as 16 microhenry. Okay, so for making this 16 microhenry, what you have to do, this particular L value you can utilize, let us say a 22 microhenry will be a sufficient. Okay, so you can go ahead with 22 microhenry, or otherwise even 15 microhenry will do the job because it is closer to 16 microhenry. So 15 microhenry will also be a sufficient value for your design. Okay, coming back to 1.8 volts, so as you are going to lower and lower voltage output, so let us say I am going to design 5 volt to 1.8 volt, because these days from 3.3 volt logic it is reaching to 2.5 volt logic. Now 1.8 volt logic is also reaching, even 1.2 volt logic is also reaching. Okay, so these are the voltage logic levels that these days people are using. Okay, so what are the changes that we should do here? Input capacitor, output capacitor, you add one more 47 plus zero point 0.1 you add. Okay, so that's the requirement that you can do. Inductor calculation, if you wish to have this particular Excel sheet calculation that you want to have, okay, then you can put a request and I'll send it to you as well. So let us say 1.8 you want it, then the inductor value calculated is 12.5 microhenry. Okay, so the advantage that we are going to get is, what we did, we studied complete data sheet and we formulated all these, like voltage level settings, inductor values, output capacitor settings, and input enable lockout value settings. Lockout value, I'll just tell you how to do that. Okay, so all these things we have formulated it, and it becomes very handy to design your own regulators for your purpose. Okay, so this is how you can do that. And enable pin, if you want, you can connect it to input pin. So we have converted, let us say, from 5 volt to 1.8 volt. Now let me just give you an understanding of how we can set it under voltage lockout. Under voltage lockout, so under voltage lockout is nothing but we don't want this particular regulator to work before my input reaches to, let us say, a 4.5 volt. Okay, so I want it to set it to 4.5 volts, so that minimum 4.5 volts should be there at the input. Okay, or let us say what we'll do is we'll keep input voltage to 12 volt and convert it to 1.8 volt. Just for the design purpose we'll do that. Okay, so what we can do, let us do that. My input voltage is, let us say, 12 volt, and enable, I want it till my like voltage level reaches 9 volt, it should not switch on. Okay, so after 9 volt only it should switch on. So what you can do is, there will be two resistance that will be connected. One will be input, enable pin to input pin, which is R3, and R4 will be enable to ground. Okay, so in that case you can see, if you set the value of R4 to 300 kilo ohm, R3 will become 2.4 mega ohm, that is 2400 kilo ohm. Okay, and let us say R4 I set it to 100 kilo ohm, then it will become 800 kilo ohm. Like that you can set it. Okay, so let us say I'm going to set it up to 9 volt, like below 9 volt it should not work, the output should not come. In that case this comparator will not be enabled and it will be in shutdown mode. That's how it does the under voltage lockout. Okay, so 100 kilo ohm and 800 kilo ohm you can put it at the input. So let me just do in this here, 1.8 volt I am doing, right? So let us say we want to connect a under voltage lockout. So put it like this and put this R3 value and R4 value. So what I did just now, R3 is 800 and R4 is 100 kilo ohm. Okay. So 800, sorry, 100 kilo ohm and 800 kilo. Right, right. R4 is 100, R4 is 100 and R3 is 800. Okay. It is just opposite. Okay. So you make it 100 and 800. Let me just write it again. 800 kilo ohm and 100 kilo. So this is how you are going to design this enable pin having a under voltage lockout for the 9 volt. So let us say I am going to work this, not this one, 1.8 volt. So this is my 800 kilo ohm, and this is my 100 kilo ohm, and this is going to be how much? 12 volt input. So I don't want this to enable before 9 volt input. Okay, so let us say my input voltage is dipping down to 9 volt and I don't want it to work below 9 volt. So up to 9 volt it will work, and after that only it will start. Okay, so that's all. If you want to design the output voltage regulators, like to regulate the output voltage to 1.8 volt, like you need to design this particular resistance values, that is R1 and R2, right? So what will be the value of R1 and R2? Quickly we will do. Let us say we'll put 1.8, then what we are going to get? R2 value will be 150 kilo ohm, let us set. Then R1 value will be 73 kilo ohm. Let's set R2 value as 220 kilo ohm. Then R1 value will become 107 kilo ohm. Okay. So we can do one thing. This will make it 107 kilo ohm, and this one will make it 220 kilo ohm. So this is how you can make the changes. Okay. Let's move to the another regulators. So some more applications were given. So you have 3 more application. Quickly we will do. So let us say we want to design 12 volt regulator. So 12 volt regulator C out can be reduced to very low value, which can be as low as 22 microfarad. If you want, you can keep it one more, according to me, one more 22 microfarad plus 0.1 microfarad will be required for you, and do the same thing with the input capacitor. You keep it, let's say, 47 microfarad or 22 microfarad, but make sure the voltage rating of the input capacitor must be closer to, let's say, what do we want to do? We want to convert it 15 volt to 12 volt, or let us say 18 volt to 12 volt, or let us say 24 volt to 12 volt. Okay, so up to 24 volt if you are using, then keep the voltage rating of the capacitor to minimum 50 volt or something. Okay, so this will be a good value. So that's the reason to use the input capacitor, utilize electrolytic capacitor of, let us say, 100 microfarad with rating of let us say 50 volt or 63 volt. So that will be a good idea. Okay, and similar to that, input you can enable pin, you can connect it to input, and you are going to get your all other values as well. Now let us design this particular resistor divider for this purpose. Okay, so what we will do is we are going to have 12 volt output, and what will be the inductor value and what will be the resistor value. Okay, so come back to this Excel sheet, put 12 volt output we need. So let us say if we set this value to 100 kilo ohm, then in that case we will need 890 kilo ohm as R1. Okay, so if we set this value to, this is 12 volt, right? So in this 12 volt we set the value, let us say 100 kilo ohm, then this will be 891 kilo ohm. Okay, and what will be the inductor value? So the inductor value we are going to get for that purpose 63 microhenry. So you can keep it 68 microhenry. Okay, so just remove this and put it 68 microhenry to use your 12 volt regulator. So this is the fact that we are going to understand. Let us say we want to change it to 15 volt to 12 volt output. or 18 volt to 12 volt output, just now we saw, right? So we can make these changes and utilize it. Let's move to another application. So if you want to have, increase the frequency of operation, so just increase this frequency of operation by setting the different value of resistance. Okay, so they are using very high frequency of operation, which is 2 megahertz, and in that case you can see now it has been reduced to just 10 microhenry. So let me just show it to you how it can be calculated. So if you set the output voltage to 5 volt, and you can see the value of resistance is right now 28 microhenry, that we had used it 33 microhenry for our 5 volt application. Now let us say we want to change this particular switching frequency to 2000 kilohertz, okay, that is 2 megahertz. Then you can see it has reduced to less than 10 microhenry, that is around 10 microhenry. That's the reason they have used 10 for 5 volt application, they have used 10 microhenry at 2 megahertz application. Okay, so that's the change that you can have. So alright guys, hope you had a good understanding about this particular, data sheet of switching regulator, which is LT3970. And our main purpose was to make you understand through a data sheet what are the information that we need to, take it from the data sheet immediately, so that our design incorporates all the design and detail values and whatever the very important information that is needed from any of the data sheet. Let us say it is analog devices or linear technology or Maxim integrated, or even other companies like Texas Instruments or Renesas, or Microchip, or any other companies, for your understanding. The main purpose is how we can design a reliable uh, switching regulator for our suitable application that you can have for your hand. So hope you have a good understanding about this particular application design after the dataset design detail. If you do need any situations or any questions do you have, please put down your comments in the comment box and we shall be able to answer you out. Thank you.